Hi all, welcome to a new session of SolveWorks video tutorial series. I hope you all are enjoying and getting benefited from this series. This is a new session number 4.3 Advanced 3D Modeling Exercises. Here in the screen you can see a mechanical assembly consists of various components like pins, levers, spring, valves, valve boxes. In this session we are discussing about same components, 3D modeling of mechanical components like spring, nut and bolt, valve, cam, etc. And also we will see some advanced 3D geometries. I hope this session will be much more interesting as we are going to discuss with real life mechanical components. Thank you and enjoy. Before starting this session, I would like to add one important point that I mentioned in my previous video also. We are going to discuss about advanced 3D modeling exercises. In order to get maximum benefit out of that, you need to know clearly about 3D modeling commands and 3D modeling basic exercises. So I'm strongly recommend you to go through 4.1 and 4.2 before proceeding with the video. And if you are comfortable with the commands and you want to check a particular command, you have an option there under the video. I'll show you one example. See, click over here. It will start the video and you can go to the description, show more. So all the commands are listed here, including the conversion tools, editing tools, plane, extras, everything that I had discussed in the video. If you want to check something specific like a sketch driven pattern, you can click on the time. That will take you to the same place. So that's the option available for you. And also some other commands like 3D modeling exercise PDF, you can download it directly from here, and all the previous videos are listed out of it. And one other thing is, this facility is available with most of the videos. Say for example you want to check the commands of sketch, you can go to sketch option and here it is listed, and you can go to a specific place. You want to check the dimension option, you want to check the editing tools, you can check over here. If you want to check some exercises like a sketch exercise number 7, 6 or something, you can click on that. That will take you to the same place. So make maximum use of this provision. The exercises that we are discussing in this session are: first one is spring, second one turbine blade, third one nut and bolt, fourth one spur gear, fifth exercise is elbow, sixth one is valve lifter, and the last one, 7, is Allen bolt. The first exercise in this session is a spring. All the dimensions of the spring is given. Here we can see that the length of the spring and the number of turns is given. If the pitch of the spring is also available, we can directly put in the SolveWorks for completing the figure. Mean diameter is given 300 and the wire diameter is 30. In SolveWorks, there are two methods for completing a spring. Either we can go with the direct helix method, or we can use the swept boss option. First I am going to show you the first method, that is by using the helix. I'm taking a new figure here, go to part. Now I make sure that the unit is mmgs. Sketch option, I'm selecting a plane, I'm selecting the front plane now. So go to a circle here, it's given, it's 300. This is the, so fit it to screen. Now exit the sketch. So 300 is the mean diameter, it's given here. So the mean diameter 300, a circle. I'm going to convert this circle as a helix now. Go to helix and spiral option. I'm selecting this one. Now here we have a number of options, like you can give the pitch and revolution, height and revolution, height and pitch. So I'm going with the height and revolution. Those are the two data we have. The height, it's given, it's 1000, that is 1 meter, and the total number of revolution is 16. So when I'm checking this one, we'll get the spring of required value. Now the step is, we need to give the wire diameter. Wire diameter is 30. In order to start the wire diameter, we need to make a plane in the tip of the spring. To make a plane in the tip of the spring, as we discussed in the previous session, go to reference geometry, go to plane, select the tip of the spring, and then select the spring itself. So now it is fully defined and it's already created a plane over there. Click and go for sketch. Now this is the area we have. We need to draw a circle of diameter 30. So I am starting a circle of diameter 30. Now exiting the sketch, I'm hiding the plane, and we can go with the swept to boss option. See, I'm selecting the profile and path. This is my profile that should go through this path. So here it is. Now we can hide the helix. I'm hiding the helix now. So our figure is ready. I'm removing the borders. So this is it. Now I'm going to explain the second method to draw the same figure. The second method is by using the swept to boss command. In swept to boss command there are two options, like a profile orientation and profile twist. We can use that particular options for creating the spring. Here what we are going to do is we are going to use the height or the length of spring, that is 1 meter, and I'm going to draw the wire diameter as a circle at a distance from the center. This is 150 as the diameter of the spring is 300. So this gap is 150. Then we can give the number of turns. I'll show you how to. So you go to file and take new, the new part, and we need to draw a line of height. See here I have a line of height 1000. I'm keeping the dimensions, so here keep the dimensions here. Now we should not draw the circle here itself, because this circle and the line is considered as a single sketch. We need to make the line and the circle as two separate sketch. For that purpose we need to exit the sketch. Now go with a new plane. I'm selecting right plane, go for sketch. So here you can see that this is sketch number 2. What I'm going to draw is sketch number 2. See here I'm taking the snap from here. Draw a circle of 30 mm diameter. I'm keeping the diameter 30 mm at a distance of the center. This distance is 150. Okay, now again exiting the sketch. Now I have two separate sketches, sketch 1 and sketch 2. Now I'm going to features, swept to boss. Here I need to select the profile. I'm selecting this as my profile, and it is asking for the path. This is my path, and here we have an option. Go to options and keep normal constant. We need to specify the twist value as a revolution, and I need 16 revolutions. So just give the value, and that will be automatically updated as a, here you can see that automatically updated as a spring. So this is the method for drawing a spring by using swept to boss option. Now we can assign a material for the spring, and also using the render tool we can make it to be look like a real one. And in order to assign the material, two options are here. Here we can see that a material option, you can go for edit material. This will go to the material library. When we are assigning any of the material out from here, this will give all the properties. So for example, if I am selecting something here, you can see that it will give all the properties also. But in our purpose, current purpose, we don't need to give any other properties. We only need the appearance. But in the analysis, like static analysis, dynamic analysis, we need to assign a material with all the properties for getting the correct result. So here the option is we can go with the appearance only. So it will give you an appearance of that one without giving any property. I'm taking steel, polished steel. Here it is assigned. Now we can go for the final render directly. The rendering process is purely depends on the performance of your computer. If you have a good graphics card and a good RAM, it will finish in a couple of seconds. It will not take much time. Now it is rendering. Here you can see that it's completed around 40% now, and 90, it's done. So this is our final result. Now it is looking like the real spring object. We can save it as an image file also, and that's all about spring. Here we have our exercise number 2, turbine blade. In this particular figure, all the dimensions are available. They have given dimensions separately. except the dimension of the shaft and the keyhole. So we can take a random dimension for those two, not a problem here. See, here what we are going to use is lofted boss option and also the circular pattern to complete the figure. And two faces are given. This is the front face, and here we have the back face at a gap of 50. And I'll show you straight away how to draw this one. Go to part, select a new, I'm selecting the front plane, and we have two concentric circles here. One is with a 65 radius and other is with a 205. Then we will join by using a center line here, center line. Now at an angle of 1 mm gap there is another two lines. So I'm starting with the circle. See, the first circle is diameter is 130, radius 65. Now another one is 410 also. So we can retain all the dimensions. I'm taking this as, okay, this is same direct dimension, but we need to represent by using radius. Here also go to dimension and the radius is 65. Okay. Now I'm zooming this area. First we can connect the center line with the quarter point of the outer circle. Now using the line option we can draw two lines, and as per the figure these two lines are 1 degree gap. These two lines are 1 degree gap with the center line. So I'm going to take smart dimension from here to here, it's 1. Here also it's 1. Okay, here from here to this one is also 1. So it's done now. So we can remove the extra portion. I'm trim away this portion as well as these two, and I'm removing this also. Now I have one portion here, so we can maintain the dimensions. So all other things are fine now. Now according to the figure, here we have the back portion that is at a distance, the same thing at a distance at an angle of 8 degree of a distance 50 mm away from that. So what I'm going to do is I'm going to make another plane at a distance of 50 mm away from the front plane. So the figure is in the front plane. I selected the front plane. Now I'm going to make a reference geometry here. I'm exiting the sketch first. Select the front plane. Go to features. Go to reference geometry, plane. The plane should be at a distance of 50. So 50 in the reverse direction. Here it is. Okay. Now I have another plane here. I'm selecting the plane and go for sketch. Spacebar and make it normal. Now I'm using the same method. So here we will get the snap. No need to give the dimension again. Now I'm drawing the second circle. Here also you'll get the snap. Now I'm making the center line from here to here. Then this time at a distance of from here to this center line 8 degree. I'm giving 8 now. So now the same procedure, like two separate lines at an angle of 1 degree each. So here we can zoom and set it up. So this angle should be 1 degree. Here also 1. So again we are removing the extra portion, removing this one, zoom it, and see, I'm taking it back because I removed this one also. No need to remove the circle, we need to retain the circle here. So here now the outer circle. Now we have the second portion. Here we can check. Okay, I'm exiting the sketch. Now we have two separate portions, and we can connect these two by using the lofted boss option. I'm using the lofted boss here. Here is the lofted boss. Then I'm joining this edge with this one. See? So one end is connected. This is the blade we required. Okay. So here is the connection. You can see the connection also. And I'm hiding this one. See? One is fine. Now we can use the circular pattern option for making the blades all over the circumference. I'm selecting the circular pattern option. Here we need to select the circle. This is my circle and 360 degree, and I'm going with the 13 number of blades I required. In the features and faces, I'm selecting this one. Okay, this is the preview we have. Once we click on this one, that will be set over here. So the total 30 numbers of blades are over the surface now. So it's done. Now we can go with the center portion. The shaft diameter, I'm considering the shaft diameter as 50 and the keyhole height and thickness same 10. So I'm going with that one now. So I'm selecting the center face, go to sketch, spacebar and make it normal. Then go to circle, here it is, it's 50. So give the dimension here, 50. Now we can prepare the keyway here. I'm using the center rectangle. So I'm taking this as 20 and 10 here. And I'm trim away the extra portions. This will be 10. Fine. So this will make some changes in the dimension. We can fix it. So it is now 10.51. Make it 10 again. Then exit the sketch and cut it by using extruded cut all the way through all. Okay, now the turbine is ready. We can go with the appearance option now. I'm going with the plastic, high gloss plastic. Different colors are available. I'm preferring yellow. So this is the one. Now I am going with the render tools, final rendering. So the rendering is initiated. Okay, here we go. 50% completed. It's going. Done. So this is our final result. Okay, that's all about exercise number 2, turbine blade. Here we have exercise number 3, nut and bolt. We will start with the bolt and followed by nut. Here the important feature is of course the thread in the bolt and nut. The thread in the bolt is created by using the tooltip. Here you can see the tooltip and also the helix. This dimensioned tooltip will sweep along the helix to complete the thread in bolt. But nut, the thread is in a different manner. We are going to introduce a new feature command which is called combine. In the combine option we can add or subtract the material. It is similarly like the assembly. Okay, straight away we'll go for the drawing. Here we go. I'll start with a part. Go to sketch, new sketch. I'm selecting the front plane now. I'm starting with the head of the bolt, and for that purpose I need to draw a hexagon, a regular hexagon, and I make the one edge horizontal. Now go with the smart dimension. This dimension is given, it's 18.6. okay, now I'm exiting the sketch. See here 18.6 and the thickness is 7 also. So I'm exiting the sketch, go for extruded boss of distance 7. Now the next step is, as we discussed in the part 4.1 of this video tutorial series, we need to prepare a chamfered portion. Here we have a chamfered portion in the nut as well as in the bolt. So we need to prepare this portion. We have a method for that one. Either you can use the revolve cut option or you can go with the option that we explained in the 4.1. So we have a quick link in 4.1. See, here it is. Here we are explaining about how to prepare. Here, see, this is the method. You can go and check in part 4.14 a detailed study about how to prepare chamfer over the bolt and nut. Here I'll show you. Click over the surface and go for sketch, spacebar and make it normal. Now go to circle, draw a circle, exit the sketch. I'm going to use extruded cut, but I am cutting the flipped outside option. See here, flip side to cut. Now it should be cut in such a way that it will make an angle of 60-degree draft. So I gave 60-degree, it's already there. See, this is the final result. So this is what we need, the chamfer over the head. Now I'm selecting this face, and I need a circle here in the middle, circle of 10 mm diameter. I need to extrude it, and here the total length is not given, 25. I'm considering total as 45. So here it is, I'm taking it as 45. Okay, now for the bolt we need to prepare a fillet. I'm taking fillet diameter 1 in this face, and also a chamfer here. Go to chamfer, or chamfer of 1 in the tip. So 1 at an angle of 45-degree. Okay, now the pending one is the threads. So we can create a thread by using helix option. In order to start a helix, we need a base circle. So I'm going to create the base circle here in this area. So the base circle of 10 we need. So we can do one thing, click over the surface and go for sketch. Here we have an option called convert entities. We can convert, we have a circle here already. So we can convert this entity as a circle over this surface. See, it will come to this surface now. Now I'm going to, this is considered as the base circle for my helix. I'm exiting the sketch now. Go for helix option. Here you can see that the length of thread is 25. I'm considering the pitch as 2. So here is the option. I'm going with the height and pitch with variable pitch also. Here I'm selecting the pitch as 2 in the beginning, and also at 25 the pitch is 2, but I'm considering 27, that is after 25. I'm considering pitch as 2 but the diameter as 12. I'll tell you why. If I'm not giving this particular line, the thread will end at a point 25 suddenly, so that will make a break point over there. But if you are giving 27 and increasing the diameter, the cutter will go to 25 correctly, and when it is moving to 27 it will come out of the edge, and that will make a finishing over there. I'll show you what I meant to say is after completing the cutting. So here now it's ready. Now the next step is creating the tooltip. All the dimension of the tooltip is available here. So here we can see that the distance and the angle is also available. What we are going to do is we are going to create this as the tooltip, and the tooltip will go over the surface and cut away the extra portions to create the thread. And for that purpose I am selecting the toe plane, go for sketch, spacebar, make it normal. So here it is. So I need to create this one. We can start by using a triangle. So I am creating a triangle here. Here we go, and I'm connecting this with the a center line here. So, and the angle is given, it's 59, and the distance from here to the horizontal one is given in the figure. It is 1.732. Now I'm making these 3 lines, selecting by pressing Ctrl. You can go with the symmetry, so it will automatically adjust it to similar figure. Here and now I'm going to select the center line because I want to make the center of the triangle coincide with this edge. In order to do that, I can select the center here and here. Now I'll make a point in the point of intersection. Now what we need to do is I want to make this one over here. So here I have an extra point. I remove that one. Now select this point, press Ctrl and select the curve. Now we can use the PS option. It will come over here. See? So that is another relation that is called the PS. Now what we can do is we can make another circle. Another point over here. See, the distance from this one it's given. See, the tip is at a distance of 4.53 from the center of the bolt. So what I'm going to do is I'm drawing a center line by selecting the midpoint. Here is the midpoint, and I have a vertical line here. Now starting from here to here, this should be 4.53. Here it is 4.53. Okay, now the point is done. Now I can draw a circle to join over there and make the circle tangential relation with the edges. So I'm making sure in this side also it's tangent now. Okay, now I can remove the unwanted portions by using trim entity. I'm removing this one. So this is finished. Now this is our tooltip. What I'm going to do is I'm going to use the swept cut option. This will go through all the way to the helix to cut away the portions. Here you can see I'm making it like this. Exit the sketch, go to swept cut. First it is asking for the profile. I'm selecting our new sketch as the profile. This is my profile, and the path is helix. So here you can see that once I tick this one, this is the end result I'm hiding. See, here it is. At the beginning I explained about giving an additional value, that is 27 to the helix. I'll show you one more time. Here it is. Here at a height of 27 we have given the diameter 12. Because of this 12 value it is making a result. Here we can see result like this. So the cutter will come in this point and come outside and making a result, a realistic result like this. So this is the complete explanation for making a bolt. Now we are going to make a nut by using the combine option. For creating the nut we are going to use the combine feature of SolidWorks. It's not commonly available. We need to take it from the library, and at the time when we are using the combined option, it is an add-on option. We are going to make some relations in between the nut and bolt, and then we will subtract the extra part. I'll show you how to. For that purpose we need to keep this bolt also. I'm saving this one, save as bolt here, saving in a new folder now, see, and I'm closing this one. We need to call it back. I'll show you. Making a nut is very simple process. We need to keep the 18.6 and the thickness is 7, same like here. So I'm going to start with the front plane. Same procedure, start with the hexagon, this one horizontal, and we can, this distance is 18.6, and I need to draw a circle in the middle. The circle should be less than 10. I'll tell you why, and I'm keeping the dimension here also. So we are going to use the combine feature of SolidWorks. In combine feature there is an additional option called subtract. So in order to subtract a particular quantity from one part to other part, the size should be different. If the size is same, like the size of the nut and the size of the bolt is same, then there is no subtraction options. So I'll show you later in detail. See, here it is. I'm giving 7 now. So now we can use the same option for the chamfer. I'm selecting this face, go to sketch now, and by using the circle option, see, this is the one, and now exiting the sketch, and I can cut away by using the extruded cut, flip outside at an angle of 60 by, see, here it is. I can mirror it. For mirroring, I need a plane in the middle, so I have a plane now. This is a common process. Now I'm going with the mirror. This is the plane I have, and this is the feature I need to mirror on the other side. So here it is. Hide the plane. Okay, now I can go for the chamfer. Chamfer this side 1, and in the other side as well. Here it is. So here we go. So here it is. Now the pending thing is the thread only, and in order to create the thread, first we need to call first we need the combine option. So I'm right button, go to customize. So I need a new command. In order to get a new command, go to the command tab. This command is relating to feature, so you need to go to the feature option here. So here it is. So here you can see that combine. Just drag and place over here. Okay, now combine is here, and I need to call the bolt back. For that purpose, we can use insert option. Go to insert. There is an option for calling the part. This is part, and I can call the bolt from here that I already saved. In this particular stage, you need to make sure that the locate part option is already checked in. Otherwise, we cannot give any relations. So here it is. Now in the left side, you can see a number of mate settings. Mate is a part of assembly. In the next session, part 5.1 of this tutorial series, we will explain about mate very detailed. So here for the time being, I will show you how to. And before starting that, we know that the outside diameter of the bolt is 10 mm and the inside diameter of the nut is 8 mm only. When we are combining these two things together, some 2 mm part of the bolt will go inside the nut. So that part can be subtracted later. So before that, I am going to join them together. Use the concentric option. I'm selecting the outer surface of this one, and also here, see, so it is now it is concentric together. I add one relation. I want to make this one over here. So in order to make that, I'm selecting this face and also this face. It will go with a coincident relation. I want to make a little movement here. So here we have the option making a 10 mm distance, flip the direction. So now it's perfect. Add the relation and click it. As I discussed earlier, here we can see that now the outside is 10 mm and the inside circle is 8 mm, means some part of the bolt is already inside the nut. Inside in the sense it is going in this direction. Now using the combine option, subtract. I need to subtract the thread portion from the bolt. Here I'm selecting the main body as my nut. So I'm going to subtract this area. So my body to combine is this one. So here you can see the preview. As it is intersecting each other, there is a thread already created. Go for OK. That will give the thread completely. So here you can see the thread has already created as we subtracted the extra portion from the main body. Now I can call the bolt again. So here it is. I am using the option of the concentric again. So here it is. Okay, now the next step is to render it by using the render tools. Here we go and go for the edit appearance. We can assign some material, and here we can browse the material. I'm going for a metal, steel. We can go with any material. Here we have the polished steel. I'm going with the brushed steel. It will not be that much polished, but it is looking like some rough look. So here you can go for final render. Here we go. It's rendering now. I'm going. Okay, it's finished. So this is the final result. As I discussed earlier, in the part 5.2 of SolveX video tutorial series, we will see the assembly of these two components again. There we can make the movements by using screw options. So at the time when I am rotating the nut, it will go along to the surface that we will discuss in 5.2. So here is our exercise number 4, spur gear. The nomenclature of the spur gear is given and also the different values. Addendum and dedendum is representing the total height. Here this is the dedendum and this is the addendum. This is representing the total height of teeth. The face width 10 mm. This is the face width. We can achieve the face width by using the extruded boss option after completing the face. Now the number of teeth is 18. So the gear angle will be 20 degree. 360 by 18, 20 degree. The approach here is we are going to make a 20 degree part of the gear. Then we can use the circular pattern option to complete the 18 numbers. Straight away we'll go for that one. First we can select a sketch plane, go to part. Okay, I'm selecting the front plane. I'm starting with the 3 concentric circles, the base circle, the circle, the pitch circle and the addendum circle. So I'm drawing 3 circles over here. 3. Now we can convert these circles into construction geometry. Now I'm giving the dimensions. The outside dimension it's given, it's 100. So it's 100 here. Now the pitch circle diameter is 84.57. So here 84.57. And the base circle, we can calculate the base circle distance from the top, addendum circle, addendum plus dedendum. So the gap is sum of addendum and dedendum. It is coming 11.25 together, 5 plus 6.25. So I'm taking the distance from this to this one, 11.25. So all the circles are ready now. Now we can go with the one portion of the teeth. See, the total angle is 20 degree. I'm going to make half of that, then we can mirror to the other side. And the next one. So this is the one, and give an angle 10. So this is a half of that, 10. Now I need to make all other angles, 2 more lines to construct the teeth. Here go to smart dimension, 2.5. Here it is 5. Okay, now we can go for this face option. Here the face and flank I'm going to make. First go with the face, go to 3-point arc, and I can start from this coincident point to this one. Now I can make the flank portion by using a straight line connecting these two. Give a relation between these two, that is tangent, and the tangent point should be here in the line. Okay, now I'm connecting using, go with the center point arc, starting from this point and connecting to this end. Now half portion is ready and we can join them together. Here I am connecting this with the center line. Now mirror option, go to mirror. I'm selecting this one, all the portions along with this face. See, now 1 by 18th portion of the gear is ready and we can extrude this one. So this is a method we are using. I'm exiting the sketch now. Go for extrude. The face width is given. The face width is 10. So I maintain 10. So this is the one now how. Now we can give a fillet relation in between the flank and base. So I'm going with the fillet. The fillet radius is 1 here and also here. Okay. Now as I mentioned, 1 by 18th of the gear is ready and we need to use the circular pattern for completing the rest of the portions. I'm selecting this as my reference. The total number is 18 number of teeth. 18 number of teeth. Okay. Now I can select the features. I want to do this one and also the fillet. Okay, this is our final result and I'm going to make one shaft hole and also keyway. $25 and I'm using a center rectangle to prepare the, this is 6 by 6. We can remove the extra portion. Okay, now exit the sketch, extruded cut. Okay, this is our final result. Now we can go for the rendering. I'm applying, I can go with the any of the material here. So go to file render. Here it is. Okay, it's rendering. So this is our final result. So here is our exercise number 5. This is a pipe elbow. It's a very simple figure and all the dimensions are available as well. And considering this face as the front face and this is as the left side view, here we can use the swept boss and the pattern option to complete this figure. And then straight away we are starting with a new file. Go to sketch and I'm selecting the front plane. First I am starting with a quarter circle. Here we have a circle of radius 200, a quarter portion we required. So either you can draw a complete circle or you can go with 2 lines. This is 200 and here also 200. Now I can connect it by using center point arc. I'm starting from here. So here it is. Now I can remove this portion and give the dimension. Okay, now we need to make a circle of 100 that will be separated over this curve. See here, go to exit the sketch and then go to features, take a plane. I'm going to make a plane in this particular point. First click on the plane and then click on the path. So a plane is there already. See, here it is. Now click on the plane and go for sketch. See, I'm making a circle of 100. It's given in the figure. Exit the sketch. Now we are going with the swept boss option. The profile, it's already selected. The new sketch is the profile and the path is this one. Okay, here it is. So I'm hiding the plane. Now I have that particular portion in the mid portion. Now we need to complete all other portions. So what I'm going to do is I'm going to create a plane in the middle so that in future I can use that plane as the plane of reference for the mirroring option. I'm completing the rest of the portion and using the mirror I can complete the figure very easily. So the first step is go to reference, take plane. So this face and this face, that will create a plane in the middle. This will be very useful. Now I need to complete other things. See, I'm clicking the surface, go for sketch and go for convert entity. So it will automatically convert this face into a sketch. Now we have the circle there. I need to extrude that circle to 50 mm. Here we can see that, compare the figure. So here it is 50 mm, and okay, now okay, 50 is fine. Now I can use this face for drawing another circle of 150, 150, exit the sketch, extrude, the thickness is 20 mm. Okay, I'm using this face for making these circles. We have 6 holes here, 10 mm diameter. Then spacebar, go for drawing, and I'm drawing a small circle, 10. The distance from the center is not given, so I'm going to take the distance as, okay, I'm taking the distance from here to, see, the center. This is 65. Now exit the sketch and make a hole over the surface. Extruded cut of 20 mm. Okay, right. Now we can use the circular pattern. First, here, this is my circle for patterning, and select the feature to pattern. See, this is the feature I want to pattern. So it's there, 6 numbers, it's already there. Here it is. Okay, now it is ready. I can use the mirror option for mirroring this face. See, this is the plane of reference or for the mirror. Now the feature, I need this one and this extrusion, and also the, okay, in a single click it will come. Okay, it is not coming with the pattern, so we can select the patterns also. Go for edit the mirror, go for pattern. We need to add the pattern. Here it is, pattern. I added the pattern. Now it will be updated automatically. Here you can see that everything is fine now. See, okay. Now what we need to do is we need to make the circle in the middle, and also here you can see that there is a fillet of 5 mm. First I am going with the fillet. Go to fillet, give the value 5 mm, and this face and also this one. So that's done. Now we need to make the hole in the middle, the hole of 75 mm diameter. I'm selecting the front plane. The same procedure that we have used in the beginning. The only difference is we need to use the full point, like starting from here till this end. Here I am taking the line from the middle, so it will connect in the middle of this one. Go back and make it as 200, we know that, and it will hit over the midpoint here and till here, and exit the sketch. Now we can use we don't need to make a new plane over the surface because this is our reference. Now I'm using this as my reference. Go to sketch, make the circle a circle of 75, exit the sketch, go for swept cut. So this is the profile and this is the path. Here it is, here we go. So this is our final answer. Now we can go for the rendering. Next option is rendering option. Here we can go with different appearances, and I'm going with the plastic. In plastic I'm going with the satin finish now. See here, white satin finish plastic. So this is the model I have. So I'm taking this one and go for the final render. Now it is rendering by using the photo view 360 option of SolidWorks. Here is the result. So this is the final result. Okay, that's all about our exercise number 5. So this is exercise number 6. Wall lifter is a very simple figure, and we can go with a single command, that is revolved boss option, and all the dimensions are also available. Here we can see a hemispherical hole inside, and we will go with this one. And what I'm going to do is I'm going to do the half of this one, all these dimensions, then we can revolve boss to complete it. I'm going with a new part, go to sketch, selecting the front plane. So the total height is given, it's 25. Here it is. So here we have 25. Now I am starting from the base line option. So this is 4.5 and the height is 3. It's given there. And I'm going 1.5 this direction. That will automatically give a gap of 3 in the other side. So again the height is 4. Then I'm going 1 inside. Okay, 1 inside, 1. Go 11. So 11. Then 1 outside, go 4 up, then we can join it by using, okay, perfect. Now we can retain all the dimensions. So here it is 4.5, this one 3, and here from here to here this is 3, this one is 2, it's given. Okay, now this is 11, this one is 4, this height is also 4, and the radius is 3. Okay, these are the dimensions we have. We can arrange all the dimensions perfectly by using leader option. So here it is, and 11 is here. Again we have 1 4, okay, 3 here, and now almost all the dimensions are okay. Here also we need to give the dimension, it's automatically 3. Now I can exit the sketch and go for a revolve boss. I'm selecting this as my axis of revolution. Now we need to make a hemisphere. Here we can see that a hemisphere in the middle. So in order to get that hemisphere, either we can make it over here directly now, or we can make some changes in the sketch itself. See, go to sketch again, and I'm zooming this area. So this is a sphere of diameter 3, so 3 like this, and I can trim away the extra portion. See, exit the sketch will automatically update. See, this is it. Now we have a spherical portion there. Now I can make the fillets. Here I have R1 in these two sides, so go with the fillet R1 here, this face, and also this face. We need 1. See, 1. Okay, here is our result. Now we can go with the rendering option. I am going to appearance, selecting steel. You can go with any of the material. You can try different materials over here. See, even you can go with a painted one, car. Okay, I'm going with the gloss red and go with the render option. See, it's rendering now. Here is the result. So this is a painted one. You can go with any material and then complete the figure by using render. So this is our final result. That's all about exercise number 6. So this is the last exercise in this session, exercise number 07, Allen bolt. All the dimensions are given, including the necessary details. Here the details of the thread with the pitch and height is given, so that we can directly prepare the thread, and the cutting tool details are also given here. Straight away we'll go for the drawing. First take the part, go for sketch, and I'm selecting the front plane. Here all the dimensions are available, 38, 4, and I'm starting with a line. So here it is, this one 38, height is given, height is 4 in this side, 4, and we need to retain all the dimensions, otherwise it will change with the other relations. So from here it's 30. Now the height is given 6.5, and we can close the geometries. Here it is. Okay, this is 6.5 and this is 30. So now we can compare the figure. Here we can see that there is a small triangle chamfer of 0.53 at an angle of 30. So what we will do is we can zoom this area, go to chamfer, and here we can go with the two options, distance to distance and angle distance. Here I am going with the angle distance. The distance should be 0.53 and the angle I am considering 60 because I need 0.53 here and this angle will be 30. Here we can see that this angle will be 30 and the other angle should be 60. That's the reason why I gave it 60. Here you can see that when I am selecting like this, see, this will be the result. So here it is, this is 60, then it will be, I delete this one and I am giving the dimension same as in our reference. See, I'm deleting this one. Here we go. See, angle between these two is 30. Okay, we can do the same thing over here as well. So go to sketch chamfer, select this one, then go for this one, and this is 0.53 and this. Okay, now we'll go for the next option, that is revolve boss. Exit the sketch now. So go to features and revolve boss. This is my axis of rotation. See, this is the result. Now we have a flat surface over here, and next step is, here it is mentioned that the chamfer is 0.8. Here we'll have a chamfer of 0.8. So go to chamfer of 0.8. I'm giving the value 0.8 in the tip. Okay, now go for the top portion, head portion. Here we can see that there is a hexagon of 6.5 inscribed circle at a depth of 6 mm. So I'm selecting this face, go to sketch, make it vertical, go for, see, and here it is. Now this one should be, it's given 6.5, and we'll make sure that it is vertical. So click this one and make it vertical. Now exit the sketch, go to extruded cut at a distance of 6. Here it's 6. So that part is also over. Now we need to make a seating. Here we can see that the triangular seating is provided by using two circles like this. Here there is a triangle in starting in the beginning and also at the end, and the height of the triangle is 4, and another circle, a triangle, is here as well. So I'm starting from here, go to front plane, make spacebar and make it straight, go to the views and we can make a little. So here it is. Now I'm making a reference line in the center. Here we go. Now one triangle is there. See, the height is given, this is 4. Okay, now, and the angle between these two is 30. So we have one more triangle. Here it is. that is starting from the tip itself. So we can finish it like, and the angle is 30 from here to here, it's 30. Okay, now we can go for extruded cut, I mean revolved cut, here it is. So we can see the difference when we change the view to, see here it is, inside there is a circle, and we can see it clearly by using cut option, section option. See, here is the difference. So a triangle is here now, and also in this area. Now I am going with the threads. The details of the threads are given here. The pitch is 1.25 and the height is 28. Now we can use the same method that we have used in the exercise number 3, nut and bolt. So the principle, everything is same as that, and you can refer exercise number 3, the thread making. The same procedure I'm going to proceed over here also. See, I'm selecting this face, go for the sketch. I want to convert this circle and bring it to the front, this face. So I'm going to convert entity, select this one and convert, it will come to front at a distance. Now exit the sketch, go to curves, select the helix and spiral. Here constant pitch and variable pitch is there. I'm selecting for the variable pitch. Here I have the dimensions. My pitch is 1.25 and the height is 28. So what I'm going to do is I'm giving variable pitch at the time of 0 starting position, it should be 1.25. At a height of 28 also it should maintain 28. Here this should be 1.25. Okay, now see, if you are retaining like this, what is going to happen is at the time when we are using the cutting tool to cut the material, it will suddenly stop over here in this point. In order to avoid that, what I am going to do is the same thing. I am making another position 30, 1.25 pitch, but the diameter should be 16. So when the cutting tool is moving from this 28 position to 30, it will coming out of the surface. That will make a real effect. You can see once I completed the figure. So we can keep the start angle 90 clockwise, finish. Okay, so here we have the helix. Now we need to make the cutting tool. I'm selecting the front plane, go for sketch, spacebar and make it normal. So here it is. Here is the details of the cutter triangle. Here we have a triangle of 1 millimeter at a distance of 3.24. So I'm making a triangle here of 1 millimeter. These two faces, I'm making this one, not this one, this face in this way, 1. Okay, now we can make these all equal, go to equal. Okay, now the center line, when we are selecting all the faces equal, then again no need to give the 60. The automatically the angle of equilateral triangle will be 60, and we can maintain the distance from here to here. It's given already 3.24. Okay, now we can join this face, this particular point and this one coincident. So it is coming to the start point. Now what we need to, in the previous case, that is exercise number 3, we have created a plane in the tip of the helix and then make it over there. Here we can use this option also. I'm exiting the sketch now. So now I have a path and a profile. So I'm going for swept cut, asking for the profile. This is my profile and this is my path. So cutting has happened now. Now here is it. Okay, I'm hiding the helix. So this is the result. Here you can see that it is starting from a small position, that is the start angle. Here the realistic one. See, this is the advantage of giving the extra value. After 28 we have given another value 30. That means the diameter is increased and the cutting tool starting and not suddenly stopped in single position. It will go out of the surface and make a realistic effect. Now the last step, we can go for the rendering option. I'm keeping like this. So go for the rendering. I'm selecting iron, matte iron here. So this is the final one. I'm going for the rendering now. Go to render tool and final render. It is rendering now. Here we go. Okay, this is our final result. So this is the option for doing Allen bolt. So this is the end of session 4.3 of SolveWorks video tutorial series. So far we have seen different 3D models and some mechanical components as well. In the next session, that is session number 5, we are going to discuss about the assembly platform of SolveWorks, where we will join all these components by using mates and relations, and we can also give the interference and collision detection over there. Once everything is confirmed, we can take to the next level, that is called the motion study, where we can animate the assembly for further references. For example, in this session we built the nut and bolt. In the assembly, we can give all degrees of freedom to the nut and bolt to animate it. I'll show you one example. Here in the screen, you can see a nut and bolt that we have drawn in the current session. I restricted the motion of the nut and bolt, the relative motion of the nut and bolt, by using mates. Here you can see that. So once I restricted the motion, see, check it, it will not move along the axis of the bolt when I am trying to move it. So it will move only, I rotate this one. So we know that this is the relation between the nut and bolt when there is a thread in between. So these kind of relative motions and degrees of freedom can be given by using the assembly. Once it's completed, we can animate it and we can save it as a video. These kind of things we are going to discuss in the next session, session number 5, assembly of SolveWorks video tutorial series. I hope you enjoy this session and thank you so much for your patient listening. See you in the next session, session number 5. Bye bye.